Where is that PDF? So next is the satellite motion. You know satellite move, correct? And satellite move in the circular motion, correct? So in this case, what you will see, satellite move in the circular motion at a particular distance. Remember, when you throw body out of the gravitational field, you never talk about the circular motion. But in satellite, we will discuss about the circular motion. Okay, any doubt? But before that, we'll understand what is the meaning of the satellite. When any light body revolve around the heavy body, that is satellite. Okay, when you have any light body that revolve around heavy body, then you will call it as satellite. Example, we have this earth. In this case of earth, you know, example, if there is a satellite, this, it is moving in a circular path. It is moving in a circular path. So this is a satellite. Moon is also one satellite. Right? The example is moon. Moon is natural satellite of earth. Moon is natural satellite of the earth. That's why you will see that satellite are two types. One is the natural satellite. Naturally, it is present around the planet. Natural satellite. Best example, moon. Correct? Then you have artificial satellite. Human being make this. So most of the satellite we send for the communication purpose is the artificial satellite. This artificial satellite can also be two types, polar satellite and geostationary satellite. You must have heard both, especially geostationary satellite is very famous. Geostationary satellite is very famous compared to the polar satellite. Okay, so when it come to the satellite, we want to know what are the condition, how we can say a structure is satellite or not. Okay, so next topic is essential condition for satellite. Chandana, in your opinion, what should be the condition for satellite? Chandana,
Yes, sir.
what are the essential condition for the satellite? What are the essential condition for the satellite?
So, like how?
Like how you will identify when structure is satellite or not? Center of satellite will always coincide with center of planet. It could be Earth also. Example, Moon uh, center will be coinciding with the center of the planet. Understood? Any doubt? Example, if you see here, you take this is Earth, E Earth. Now this is Moon. So if you take Moon, this. So what is the center of Moon? Earth center, correct? What is the center of Earth itself is center. Example, if you take this, why? If this you take like that, so center of Earth is coinciding with the center of Moon movement. Remember, not Moon, movement of Moon. Because ultimately Moon is revolving around the center of the Earth. Yes or no, guys?
Yes, sir.
Okay. Any doubt?
No
Second,
doubts.
plane of orbit of satellite. Plane. I'm not talking about the orbit. Plane of the orbit should pass through the center of the planet. Though it will look slightly difficult to imagine, but plane of uh, satellite orbit will pass through the center of planet. Pass through center of planet. Example. Now moon is moving here at this moment. If you take this plane, it will move like this. So plane is 2D, right? So this plane will pass through the center of Earth. If you take moon here, then its plane will be like this. Make sense, guys?
Yes, sir.
So plane will move through the center. Understood? Any doubt, guys?
No,
Because
sir.
this plane part look difficult. Barinder, any doubt about this plane of orbit? Plane 2D.
No, sir.
And then, if you have no doubt, there is a third point that satellite can revolve around the Earth only in those circular orbit whose center coincide with the Earth center. And we already said this, right? First point was this only, correct? We said first point is key satellite center coincide with the planet center. But in this case, whenever circle is drawn on the globe like Earth, so it should coincide with the greater circle. Example, I will tell you what I am trying to convey. Example, you have this Earth surface. Here, satellite is moving. If you see, this is having this kind of plane, correct? So this plane will be correlated with the plane of the center, like parallel to this. This plane is parallel to this. But this is not stable. If anything is coinciding with the center, it will be more stable. So point is same like second point, but third is we are talking about stability. Understood? Any doubt?
No, sir.
Okay. So that's the point. You can rub this because it is the same point. It's just that key it will be more confusing that plane of the orbit should always pass through the center of the Earth or center of any planet. That's all. Next topic, orbital velocity. Barinder, what is orbital velocity? I told you in the previous class.
Sir, we final
This is the minimum velocity of body, so it can enter in circular orbit, right? Example, in case of escape speed, we are throwing out of the Earth gravitation field. The Earth cannot attract, but here it is moving in the circular orbit. Correct. So, example, same situation. You have Earth. This is Earth E. Here, any satellite is moving as satellite. Okay. So this is the satellite. What will you say? Ki Earth will attract this toward itself, gravitation force. and centrifugal force will be away from other side, and both will be equal. That's why net force is zero and it is moving in the circular path. Make sense? Any doubt? So you will say ki earth gravitation force will be equal to the centrifugal force. uh, Centrifugal or centripetal? Away. Away is centripetal. Okay. So outward direction, both should be equal. What is this value? G, mass of the earth, mass of the body, divided by r square at any distance, is equal to, what will be the centripetal force? Mv square by r. R cancel, m cancel. What
सर
will be your
माइनस
orbital?
नहीं होगा?
नहीं, हम फोर्स की बात कर रहे हैं ना, पोटेंशियल नहीं बात कर रहे
सर दोनों
हैं।
ऑपोजिट है ना, तो
हाँ, मतलब मैग्नीट्यूड में that makes sense, but in general what we say ki force when acting is like force, when it come to the direction then there will be negative sign for sure.
ओके
Na?
सर.
Direction में correct, magnitude wise this is correct, because when we were talking about the potential, then we said gm by r, right? Like this. Why? Because in this case potential is a scalar quantity. Understood? But force is a vector quantity. So whenever you write unit vector G m m by r square, then you will take unit vector I j k. Then you will write minus sign here. Understood? Any doubt?
नो सर.
So what will be the value? You take under root other side G m by r. Got it? Any doubt?
No, sir. No, sir.
So if you feel ki near the earth surface, very close to the earth, near earth surface, can you say this r value will be approximately equal to the radius? Then in this case orbital velocity will be equal to gm by r, and if you put all the values it will be 8.1 kilometer per second. What does it mean? Two things. One is you should know formula. Second, you need less velocity for orbital compared to the escape velocity. Any doubt, guys? If you
नो
don't
सर.
have any doubt, right question. Ki you have satellite X and Y are orbiting around the Earth in radius ratio 16 ratio 2. Find out their orbital velocity ratio. Find orbital velocity What your answer? V not inversely proportional to R. Correct. You know here radius ratio is why I wrote radio 2 times. Radius ratio. Okay. So orbital velocity of x by orbital velocity of y will inversely proportional to their radius. Correct. So it will be like under root radius of y by radius of x. Uh, Radius of x. What is this value? X by y, 2 by 16. It means 1 by 8. So velocity of x by velocity of y will be equal to 2 under root 2. Where you were facing issue, guys? What was the problem?
सर रेडियो रेशियो समझ नहीं आया मुझे तो
रेडियस रेशियो था वो. रेडियस रेशियो.
इसीलिए
Radius ratio. Any doubt?
No, sir.
So if you are done with it, we can move to the time period of the satellite. How much time is taken by the satellite? You can relate with the Kepler's law also. Time period. If you see time period in this situation, you know your speed will be equal to the distance by time. What is the speed in case of satellite? Time period of orbital motion. So what will be the speed? Orbital velocity. Distance 2 pi r. Time t. So what will be your time period? 2 pi r upon v naught. Correct. T is equal to 2 pi r. What is velocity value? Under root 2 gm by r. Take square both side. Take square both side. Square this side and whole this square. What will happen? T square is equal to 4 pi square r square divided by gm by r. What will happen? T square will be equal to 4 pi square by gm r cube. If you understand this, you can recap your gravitation Kepler's law. Kepler's third law say that Kepler's third law of period. So in this case, you know T square is directly proportional to R cube. T square is directly proportional to R cube. And then remaining will be the constant. So T square will be equal to K R cube. Correct? What is this K value? You can compare in this equation. 4 pi square by G. Yes or no, guys?
yes sir
Any doubt?
no
Anybody have doubt in this? And I can show you. We were solving questions now. Wow. I will show you in the very beginning. Look at this question. There was ratio. Escape speed. See this question 2015. It looks so long. Sani, are you there?
Yes, sir.
Yeah. So Kepler's third law states that the time period of the planet is directly proportional to third power of the distance. This, where k is constant. If mass of the sun and planet is this and this respectively as Newton law of gravitation, this relation between g and k. You know, we just did. T square is equal to 4 pi square by gm r cube, right?
Yes,
So
sir.
it said t square is equal to k r cube. So r cube common, t square common. It means k value will be this. Right? K
Yes,
value will be equal to 4 pi square by gm. It is asking relation between k and g. So can we say g mk is equal to 4 pi square? See, question is so long, but your answer is very short if you know the topic. Make sense? Question is very long, but your explanation is very short. Ooh, done. Same here. It is asking you can solve both the question 58, 59. First do sorry 60 because it is easy.
times.
Can you write escape velocity like this? You write like this under root 2 gm by r, correct? If you
Yes.
take under root 2 outside gm by r, what is gm by r? Orbital velocity. Tell me guys, was it really difficult?
No, sir.
Solve 59th question.
Sir,
Yes, Chandana.
sir, what you did after satellite question?
60th question. Relation between escape velocity and orbital velocity. I will write here also. If we calculate relation between the escape velocity VE and orbital velocity VO, we are asking relation. We know VE is equal to under root 2 gm by r. VO near Earth surface will be equal to gm by r. Correct? Can we write this as this under root 2 multiply by under root gm by r? Or can we say this escape velocity will be under root 2 time of the orbital velocity? Any doubt? Any doubt?
No, sir.
Hmm. So I'll finish remaining part, then we'll solve question. So next is, in case of satellite, how calculate different type of energy? Satellite energy. So first, kinetic energy is equal to half mvo square. What is O? Orbital velocity. Correct. Half m. What is v orbital value? Under root gm by r. Correct. Square of this you can remove, right? So we can say kinetic energy will be equal to half of gm m by r. Done. Easy. Kinetic energy equal to half mv square. Done. You know v orbital value. Correct. If you calculate potential energy is easy because of the height minus g m by r. Done. We already know this. If you calculate total energy, this total energy TE will be equal to kinetic energy plus potential energy. Kinetic energy is half and potential energy is minus 1. So minus 1 and plus half will be equal to minus half. Any doubt? We did same stuff in the atomic structure also, and I told you we will do same thing. If you see, total energy is equal to kinetic energy, but in the negative sign. Okay. Total energy is double of half of potential energy. Correct.
Yes, sir.
Total energy, kinetic energy. If third, you can relate kinetic energy and potential energy, so you will say kinetic energy will be minus half of potential energy. I wrote the same relation what we have above. Nothing different. Yes or no, guys?
Yes, sir.
Yes.
Why this? Why this total energy is negative?
So because potential energies.
Because it is in the binding state. It is still attracted by the earth. Correct? Because ultimately this is binding energy. In the binding state means attracted state. Understood? Because binding state means attracted state. What will be the binding energy? What will be the binding energy? Binding energy is what is the minimum energy required to the binding state. Like now satellite is binded with the earth. That's why satellite is revolving around the earth, right? So what is the minimum energy required? So your satellite can escape from the earth gravitational field. Okay, so basically satellite will lose contact. Correct. So you know binding energy and total energy is equal to 0. So whatever is the total energy, sign will be ulta. Why? Binding energy is equal to minus total energy. Total energy is equal to minus 1 by 2 G M M by R. Correct. Why it is positive now? Binding energy is positive, but total energy is negative. Binding energy is energy you need because you have to invest energy. It is positive. You require energy to release, right? Any doubt?
No, sir.
Huh. Example. I will ask you simple question. If radius of orbit of satellite increase, what will be the impact on the kinetic energy? Anvit, not Anvita. This, Sania. Decrease. Why? Because we know kinetic energy inversely depend upon R. Make sense? Sania. Yes.
Yes, sir.
Barinder, what will be the relation of the potential energy with radius?
Inverse.
Directly.
Inversely.
Directly. Why? With R it is inversely, but you have minus sign, na?
Yes,
Yes.
sir.
Minus sign. Minus sign. That's why your potential energy will increase. Chandana, what will be impact to the total energy?
Sir, kinetic energy increases.
Ki- Total energy, total energy. Kinetic energy decrease
Yes,
when you increase R. Total energy
total energy increases.
increases because negative sign. Remember, because of the sign. Here you have negative sign, here you have negative sign. Sign is the issue. Otherwise, it is inversely. So total energy increases. Correct. Uh, Sania, what will be the impact on the orbital velocity?
Sir, decreases.
Decrease. Barinder, what will be the impact on the time period?
Increase.
Increase. How do we know? Even if you don't know formula, logically you see कि whenever you increase radius, so it will be away from the Earth atmosphere, right? Then basically velocity will decrease, kinetic energy will decrease, right? When you increase radius, speed decrease. Close to the Earth, speed increase, right? Whenever speed increase, time will taken less, correct? When speed increase, time taken less. When speed decrease, time more. Make sense? So all these things are logical rather than like you have to memorize the thing. No, you don't need to memorize anything. Any doubt?
No, sir.
What I left? Work done to shift the orbit of the satellite. Like if you shift from the one orbit to another orbit, what will be the work done? Work done to shift orbit. It means you are changing orbit from one to another. Example, this is Earth. Satellite was moving here in first orbit. Now you are shifting to the second orbit. Then there will be change in the work done, right? You have to do external work done. Make sense? Because you are shifting the orbit, you have to work. Correct? It is attracted toward inner side. You are taking it outer side. You have to put force. So what is the force of this work done? Change in the energy. Correct? Change in the energy. How to calculate change in the energy? Final energy, total energy final minus total energy initial. Correct? You put the value, you get the answer. Correct? Example. In case of final value, let's take this radius is R2. This radius is R1. Correct? So what is the final value? G M M by uh, final value G M M by 2 R2. Correct? Minus G M M by 2 R1. Correct? Because your total energy formula is minus G M M by 2R. Any doubt, guys?
No, sir.
No, sir.
That's why minus minus will become plus. So can you take your external work done? G M M by 2 is common. One value will be R1 minus R2. That even if you don't know this derivation, still you can do it. But what is the role of derivation? See, derivation beauty is you can do even without explanation. But when you do it, you have habit of doing it. Then you can solve even an unrelated question. Example, remember this rule. If I am teaching you, I can't give you guarantee that question will 100% come from this. Nobody can give. Somebody is giving guarantee ki question will come only from this. Either person is too smart to know everything, or like person is making fool of other ki oh they don't know anything. Whatever I say, they will believe. Right? But nobody can predict. What what is the benefit if you solve variety? Then you know ki even if I get new question, I know how to derive anything, how to deal with it. Example, do you think this part was difficult? Ki when orbit is shifting from one to another, you can calculate change in work done. Done. Make sense?
Yes, sir.
Example, whenever you want to uh, launch the satellite of the Earth, you will take polar side or equator side. If you want to launch satellite, you are launching satellite. From where you will launch? So you will launch near equator. Why? You know, at equator, uh, gravity value is less, but at pole, gravity value is maximum. Correct? We did this like change in the gravity value with height, with depth, with rotation, right? So maximum density, maximum gravity at pole and minimum at the equator. You know, when you launch near equator, G value will be minimum. And if G value is minimum, you require less fuel. Make sense? Any doubt? And easy to set. Any doubt, guys?
No, sir.
Last topic of this chapter, you have two type of satellite. One, one is the polar satellite. Polar satellite says that ki it rotate in the polar plane. And you know what is the meaning of the polar plane. See, if you have Earth, like round Earth, then this will be the equatorial plane, right? around the equator, and this will be the polar plane. Any doubt? This is polar plane. Another will be equator plane. Okay. So what is a polar satellite? A satellite that rotate in the polar plane. Correct. Here, usually height is very less in case of the polar height. That's why they can easily rotate in the this. So usually you will see height in the this situation is hardly 500 to 600 kilometers, not more than that. Time period is also very less, like hardly 1.5 hour, 100 minutes, not more than that. But why we are using this polar satellite? Answer is to check the weather data. So we collect weather data. What is the weather spelling? Any doubt?
No, sir.
Which satellite is left?
Artificial.
Geostationary. Because
Geostationary.
even this polar satellite or geostationary satellite, Channa, all these are the artificial satellite, right?
Yes, sir.
So last topic of this chapter is the geostationary satellite. What is the spelling of the satellite? Geostationary satellite. Okay. So this is satellite that move around the Earth orbit in the equatorial plane. So what is the difference between the polar and equatorial geostationary satellite? Type of plane you are using. Correct. Here this is the Earth. Then geostationary satellite will. This is geostationary satellite. Correct. You said, like we said, time period in polar satellite is very less, like 100 minutes. Here, it is taking time almost same as the Earth rotation, about 24 hour time period. Good. So that's why you will see geostationary satellite will not look like it is moving. Why? Because time period is both same. It look like this satellite is always fixed. Because with the frame of reference, there is no motion. Earth speed and this speed is exactly same. Use. It is used in many way. I wrote distance now. Height was this. Here height is very, very, very high, like around 36,000 kilometer from the Earth. So it's way, way, way much. Correct. And application, lot of example communication. In weather data collection, polar, but communication mostly this. Broadcasting, RTV, broadcasting, RTV, and all the thing like all the communication devices are acting on the geostationary satellite because there is no time lag. Earth is moving with the same speed, so there is no issue. Correct. Radio you used to use same the satellite. Correct. Any doubt?
No, sir.
Remember one thing. It appears stationary from the Earth's surface. That's why geostationary appear stationary from Earth's surface. Why? Because with the relative velocity zero, both moving with the same velocity. Okay, and mostly in all the system example, even in the GPS, you use the same. And with this, gravitation chapter is completely done, guys. I made notes from. Any doubt? Any topic I missed from this? Kepler law are given here. I wrote in the last time. Kepler's law not written here, but I taught. If
Yes,
you
sir.
face any issue, let me know. Example. For satellite moving the orbit around the Earth, what is the ratio of the kinetic energy and potential energy? Kinetic energy half, correct? And potential energy is -1. So kinetic energy by potential energy will be 1 by 2 by 1. That's all.
Yes, sir.
Satellite of mass m orbiting around the Earth in a circular orbital with velocity v. What will be the total energy? Kinetic and total energy is
Option
equal to minus half of the kinetic energy. No. Minus of kinetic energy, my bad. How do I know? Because kinetic energy is plus half, potential energy is -1, and total energy is minus half. Understood? Everything else is same. G, M by R, everything else is same. Only this number changes. Make sense?
yes,
Kinetic energy half, potential -1, total minus half. So total will be equal to kinetic energy in the minus. Correct? So what is the kinetic energy? Half mv square. What is the answer? The reason why I am not solving all these questions because these are way easier. Okay. But those questions were a little bit difficult. That's why we did this. Example, if you see here, last question of the this chapter. Satellite is orbiting just above the uh, surface of the Earth with the time period T. Density D and G is this. What will be the value of this? Now you can compare with time period. T square is equal to 4 pi square by gm into r cube. Correct?
yes,
Instead
sir.
of mass, you can take density. So mass will be density into volume, and volume will be 4 by 3 pi r cube. Correct? Right here, T square is equal to 4 pi square r cube divided by g. What is the m value? Density into 4 by 3 pi r cube. 4 cancel, 1 pi cancel, r cube cancel. So what will be your 3 pi by 0 T square? Tell me, was it really difficult? Direct formula based. Here, instead of m, you have to write density value. That's all, density and volume. Make sense? Any doubt, guys?
No,
Ask your questions.
सर नोट्स ओपन कर दो एक बार.
Sure. See, we wrote same thing. Where is this? T square, this formula. 4 pi square gm. Just write instead of m density and volume and do it. परिंदे तुमने एंड में नहीं लिखा था क्या?
सर लिखा तो बस थोड़ा सा मिस हो गया.
So Sania and Chandra, send me your notes.
Sir, I was not there for time period explanation.
Time period.
तो मैंने भी लेट में ज्वाइन किया था.
So both of you have half an hour. Go through the video. I can't upload right now. It will take 10-15 minutes. Okay, so both of you can send me after the class. Okay,
Sir, I was
7
not
o'clock.
there for only time period.
Yeah, so only for the time period. No, but you need explanation now for time period.
Yes, sir.
Yeah, so I will upload in next 15-20 minutes, and then you go through it and you send me notes after 7 o'clock,
Yes, sir.
after your chemistry class.
Okay.
I think one of the advantages of this class ki we are not having class together, right? Like it's not too much burden ki you have to sit for 6 hours continuously and attend all the classes.
Yes, sir.
Is it good or
Sir,
you
I
feel?
wanted to ask something.
Yes, Sania.
Sir, you asked about the test yesterday,
Huh.
samines and biomolecules.
Ye- Yeah, today you have biomolecule and amines test, correct?
Yes, sir.
Huh.
So we be having the class or not?
No, no, there will be no class, only test. Like no video call, only test.
Okay, sir.
Yeah.
So what will be the timing of the test?
9 o'clock will be good enough.
Okay, sir.
Yes. How many questions should I give? 20 question? 40? So maximum you will have class up to 7 o'clock. So you'll get 2 hour for the quick revision. Do proper revision. Even
Okay,
if
sir.
you send notes later in the night after test, it's okay, but prepare well for the test. अर्थ आयता?
I too, sir.
Right.
That's all, guys, for today. See you after 25 minutes.
Thank you, sir.
Okay, bye.
Thank you, sir.
Hmm.